Now my dear students, today we are start the chemical kinetics chapter. It's a chapter number 10 my dear students in crash course. Now in this crash course my dear students, we can see the variety of questions numericals which are asked in NEET exams. We can see the formulas as well as we can see the learn. I give you small techniques, small formulas which are given in this chapter. Now my dear students, we can go through the questions and complete this all chapter from this. These are the questions with the concepts, theory and formulas. Now my dear students, we can see here question number 1. My dear students, this question number 1 is asked in NEET 2019, and what is the question number 1? It is for the chemical reaction N2 plus IH2 to give rise NH3. The correct option is, my dear students, you can see the rate of reaction. What is the rate of reaction? Here we can see the rate of reaction formula. Rate of reaction. Rate of reaction is the number of moles of reactants and that equal to number of moles of product. Now we can see here that is a dN2 upon dt and that equal to 1 upon 3 dH2 upon dt and that equal to 1 upon 2 dNH3 upon dt. Here my dear students, these are the reactants, N2 and hydrogen are the reactants. That's why you can see here sign is put is negative. My dear students, here negative sign is put because in this negative sign, these are the reactants. When reactants are present, negative sign is only shown for the reactants my dear students, and positive sign is present for the product. Now we can calculate the here concentration. These are represented as a concentration. So you can see here concentration my dear students. Here we can see the correct option. What is the correct option? This is the relationship between hydrogen and ammonia. You can see in the 4 options. So you can isolate the hydrogen and ammonia, because in option hydrogen and ammonia are the concentrations, and question is what is the relationship between hydrogen and ammonia. So my dear students, here 1 upon 3 dH2 upon dt, you can write the only concentration of hydrogen and ammonia is the dNH3 upon dt, that equal and 1 upon 2. Now my dear students, when we see the only concentration of this hydrogen, so you can here write that dH2, this 3 is present above, so it is a 3 by 2 and d ammonia upon dt. So here my dear students, we can see the concentration of hydrogen is equal to 3 by 2. Here when we see the concentration of ammonia, then 2 is going to upper of this hydrogen. So you can calculate the concentration of ammonia, and that is dNH3, that equal to here 2 by 3 and dH2. But negative sign is placed because hydrogen is present in a reactant side. So here you can see where is the answer. So you can see the nitrogen, but here hydrogen and ammonia, here you cannot see correct relation between the hydrogen and ammonia. Here my dear students, now we can see the relationship of, this is a one type, here this is a one type my dear students, and second type. Now we can see the relationship between nitrogen and ammonia. Here dN2 upon dt is equal to dNH3 upon dt, and this type of formula is present. Here negative sign is present nitrogen because nitrogen present in reactant. So my dear students, your answer is D, because this D answer is correlated with this formula. So now my dear students, you can see the correct options when rate of reaction is equal to, this is called rate law, and we can define the rate law. All the reactant and product concentrations are equal. Here nitrogen and hydrogen are the concentration of this reactant. Here this is the concentration of the product, and all are equal. So stoichiometric this number is present before the concentration of ammonia and hydrogen, then you can put 1 upon 3 or 1 upon 2. Now my dear students, this is the question number 1, correct answer is D, and it is asked in 2019. NEET 2019. Now here we can go to the question number 2. The rate of the reaction twice N2O5 2 gives 4NO2 plus O2, 2 gives dN2O5 dt is equal to K N2O5, and here he asks the relationship. First of all, my dear students, we can write the rate law. Then according to rate law, rate of reaction, here the rate of reaction is equal to 1 upon 2 dN2O5 upon dt, that equal to 1 upon 4 dNO2 upon dt, and that equal to dO2 upon dt. My dear students, for reactants we can put the negative sign, and for product a negative sign is not put. Now we can see here rate of reaction of this. If you can see here dN2O5 upon dt is equal to Kn2O5. This whole is equal to Kn2O5. This is the Kn2O5. Now my dear students, we can put here 1 upon 4 dNO2 upon dt. Here when we put the relationship between K and K dash, so we can see here dNO2 upon dt, that equal to K dash and N2O5, and you can see here dN2O5 upon dt, that equal to K N2O5. So my dear students, here this equal to K N2O5. Here when you can put the here rate of reaction, that equal to minus half into K N2O5, and that equal to, my dear students, NO2 upon dt. Here NO2 upon dt, here you can put the K dash and 1 upon 4 K dash N2O5. So when we give the relationship here, this is a K, my dear students, and here K dash. This 4 by 2 K N2O5, that equal to, my dear students, K dash N2O5. If you can cancel the concentration, and this 2 divided by this 4, that equal to, you can get the 2K is equal to K dash. Now we can derive this K dash is equal to 2K. So my dear students, here A and B option is the correct answer, but you can see here this is a K double dash is equal to K, here K double dash is equal to K by 2. Now we can see here another relationship, this is the first type, and here we can see the dO2 upon dt that equal to K double dash and N2O5. Here my dear students, dO2 upon dt, in place of this, now we can here dO2 upon dt, it is a K double dash here, you can put these values. So here you can, my dear students, we can put the values dO2 upon dt, in place of dO2 upon dt, K double dash and N2O5. So we can here put the values of dt upon dO2, K double dash and N2O5. Now we can see here second relationship is the K double dash and K. So we can see here where is the relationship K, that is a dN2O5 upon dt barabar K N2O5. So we can see here when both are cancelled with each other, K N2O5 that equal to K double dash. Now my dear students, we can see here that K double dash, if you can get the K double dash, then here 1 upon 2, here 1 upon 2 is also percent. So this 2, 1 upon 2 is also percent. When you can get the only K double dash, so you can write here K double dash is equal to K by 2. So in this way you can get the answer B, because here 2K is equal to K dash and K double dash is equal to K by 2, you can get by this relationship. Now my dear students, here you can see the K double dash and K relationship. in this type of relationship you can want K and K double dash. So, when put the values and you can get the second option, that is K double dash is equal to K by 2. Here this is a K double dash N25 in the place of dO2 upon dt, because dO2 upon dt is equal to 1 upon 2 dN25 upon dt. So, when you can put the then K upon 2 you can get. Now, my dear students, we can go to the question number 3. Here you can see the question number 3, my dear students. For the reaction N2O5 to gives twice NO2 plus half O2, the value of rate of disappearance of N2O5 is given. The rate of formation of NO2 and given, my dear students, you can put the rate law. First of all, you can put the rate law. Rate of reaction for this reactants, no stoichiometric compound is present, that is why only you can put that dN2O5 upon dt, and this is a negative sign is present because it is a reactant. Now, my dear students, it is a product. So, you can put the for the product 1 upon 2 into d NO2 upon dt. Now, here you can see the half of d O2 upon dt. Half of dO2 upon dt, it means it is a 2 dO2 upon dt. It is a 2 dO2 upon dt. So, here my dear students, you can see here the value of rate of disappearance of N2O5 is this one, that is 6.25 into 10 to the power minus 3, these values. This is the value of N2O5. Now, we can see here want the rate of formation of NO2. So, my dear students, you can get the only two equations, this one. So, when this you can want this dNO2 concentration, then this 2 is given to in this side. So, my dear students, dN2O5 concentration of dN2O5 that equal to 1 upon 2 dNO2. Now, we can see here what is the concentration of this NO2. NO2 concentration, if you want the NO2 concentration, because there 1 upon 2 dNO2 is present, then 2 is go to here in this side and multiply. So, you can get the 2 into 6.25 into 10 to the minus 3, that equal to dNO2. And when you can multiply this quantity, then you can get the 1.25 10 to the power minus 2, that equal to dNO2. So, my dear students, here you can see the options B option and D option both have 1.25. This is our one part. We are calculated one part this. Now, we are calculated the concentration of O2, because here he want the concentration of O2. O2 concentration with N2O5. Then, my dear students, you can write the equations for 2 dN2O5 upon dt, that equal to twice dO2 upon dt. Because time is constant, so you can see here 2 dO2 upon dt. Here when you can get the concentration of only dO2, then 2 is divided by N2O5. So, my dear students, you can write the concentration of dN2O5 6.25 10 to the minus 3 upon 2, and that is the concentration of dO2. So, you can get here that is the concentration of O2 is 3.125 into 10 to the power minus 3. Then you can go the option B. Question number 3, correct answer is B. And this question is also asked in 2010 NEET exams. In this way, you can first of all you can, my dear students, write the formulas and you can put the values and get the answers. Now, we can go to the question number 4. Here, my dear students, for the reaction, the value of DH2. My dear students, here you apply the rate law. First of all, what is the rate law for this equilibria? N2 plus IH2. Here, rate of reaction that equal to dN2 upon dt, that equal to 1 upon 3 dH2 upon dt. Here, my dear students, you can see here negative signs are present, because here both are in reactant sides, and here you can see the product 1/2 here dNH3 upon dt. Here my dear students, here concentration of dNH3 upon dt is given by, here concentration of dNH3 upon dt is given by, and it is, this concentration is the 2 into 10 to the power minus 4. So, you can put the concentration of 2 into 10 to the power minus 4, and when this is divided by 2, my dear students, when you can divide it by 2, then you get the concentration of dN2. So, you can get the concentration of dN2, but here he wants the concentration of dH2. So, my dear students, this dH2 here multiply by this 1/3, so it comes the power. So, this, when this compound is multiplied by 3, then you can get the concentration of dH2. In this way, my dear students, this 2 and 2 are cancelled with each other, and concentration of dH2 is 3 into 10 to the power minus 4 you can get, and this is the answer, 3 into 10 to the power minus 4, and my dear students, answer fourth, that is answer is D, you can get here. In this way, my dear students, you can solve the problem. This problem is also asked in 2009 NEET exams. Now, we can see here in the reaction, question number 5, BrO3 minus aqueous plus 5 bromide ions plus 6H plus ions to give thrice Br2 liquid plus thrice H2 liquid. The rate of appearance of bromine is related to rate of disappearance of bromide ion is. First of all, my dear students, same concept, you can write the rate law, rate of reaction, that equal to, for this minus sign, for this reactance dBrO3 minus upon dt, then that equal to 1/5 dBr minus upon dt, then equal to 1/6 dH plus ions upon dt. These are the reactants, so minus sign is present, and that equal to plus sign for product 1/3 dBr2 upon dt. Then you can say here that equal to 1/3 dH2 upon dt. My dear student, this is the rate law. Now, here you can see that the rate of appearance of bromine is related to rate of disappearance of bromide ions. Here, my dear students, now you can see the questions. Bromine here, this is the bromine, and he wants the relationship between bromine and this bromide ion. So, you can now take this bromine and bromide ions, rate of reaction that equal to 1/5 dBr minus upon dt, and that equal to 1/3 into dBr2 upon dt. Now, my dear students, you can see the options. In option Br2 upon dt, here you want Br2 upon dt. When you can take the Br2 upon dt, then 3 is go away. So, you can see here 3 Br, here minus sign is placed because here these are the reactants. For reactants you put the minus sign. So, it is not a correct answer because here 5/3 and here you can get 3/5. Now, in B option you can get dBr2 upon dt, that equal to 5/3 dBr upon dt. Here, my dear students, you can get here that is plus sign, and bromide you can get the minus sign. So, it is not a in B option. Now, we can see here this dBr2, here dBr2, here you can see this is the answer. Why? Because when this 3 third go to bromide side, then you can get the 3/5, here negative sign is placed because dBr is a reactant side, and you can get the dBr2. So, my dear students, you can get the dBr2 upon dt concentration, and here dBr minus dt. So, you can see D option is the correct answer because you can get the D option here in this way. Now my dear students, we can go to the question number 6. Consider the reaction N2 plus H2 to give stress NH3. The equality relationship between, definitely you can put the red law. This is also a question of red law, and this question also come in NEET 2006. Here rate of reaction is equal to dN2 upon dt. This is a minus sign. Here this minus sign is placed for this hydrogen, 1 upon 3 dH2 upon dt. Here you can place the 1 upon 2 into d NH3 upon dt. Now my dear students, we can here see the relationship. He want ammonia and hydrogen. So you can take the only ammonia and hydrogen from this rate law. Here this one. Then you can take the rate of reaction, that equal to minus 1 upon 3 dH2 upon dt, that equal to 1 upon 2 dNH3 upon dt. Now my dear students, here you can see the concentration of ammonia. When we take the concentration of ammonia, then 2 is present above side, then you can say minus 1 upon 3 dH2 upon dt, that equal to d ammonia upon dt. This is your first relation. When you want the relationship of hydrogen, then 3 go inside, and you can see here dH2 upon dt, that equal to here 3 by 2 dNH3 upon dt. In this you can get the second equation. In this way, my dear students, you can see the first and second equation. Here dNH3, this equation bond dNH3 upon dt, that equal to dNH3 upon dt, then that equal to 2 by 3 dH2 upon dt, because 2 go upper side. So here my dear students, 2 by 3 dH2 upon dt. So you can here 2H2 upon d by 3. This question number 6, you can get the answer C is the correct answer, because here you can get the answer. This is the answer of the question 6. Answer option is C here. You can solve, my dear students, in this way. First of all, you done the rate of reactions. You can put the formulas, and here this is rate law. According to this rate law, my dear students, all the reactants, concentration of reactant products are equal in this way, and calculate the concentration of any of reactants or product. Now we can see the question number 7. Here my dear students, you can see the question number 7. For the reaction 2A plus B to give 3C plus D, which of the following does not express the reaction rate? Here you can put the reaction rate law, rate of reaction, that equal to minus 1 upon 2 dA upon dt, that equal to dB upon dt, that equal to 1 upon 3 dC upon dt, that equal to dB upon dt. My dear students, you can see here, this is the total rate of reaction for concentration of A and B. Now here, which of the following does not express the reaction rate? Here you can see A option, minus d upon 2 dt, means 1 upon 2. Here you can see 1 upon 2 dA upon dt, it is a correct. Now we can see here dC, 1 upon 3 dC upon dt, here you can see, here this is the plus, but you can see here this is the minus. My dear students, because it is a minus, so this is the correct answer, because it does not express the reaction rate, Now we can see here question number 7. After this question number 7, we go to the question number 8. Here my dear students, question number 8, 3A2 gives 2B, rate of reaction is equal to, here you can see the rate of reaction according to rate law, rate of reaction that equal to for reactant minus 1 upon 3 dA upon dt, and that equal to, my dear students, for product 1 upon 2, here 2 is present, here 3 is present, so 1 upon 3, here 2 is present, so 1 upon 2 into dV upon dt. So, here, my dear students, this is the rate equation and both are equal in this way. dV upon dt is equal to, when you can put the dV upon dt. So, my dear students, this 2 go to the upper side of this side, minus 2 by 3. You can see here minus 2 by 3 into dA upon dt. So, this is the correct expression for this. So, my dear students, this expression is present in B option. So, you can go the B option. This question is also asked in, my dear students, NEET 2002. Question number 8. Answer is B, and we can here derive this question. Now, we can go to the question number 9th. Here, my dear students, in question number 9th, for the reaction, here these are the reactants and these are the product. Which of the following relations correctly represent the consumption and formation of product? My dear students, you can write the rate of reaction and rate law, and after the rate of reaction you can see the options. Here for reactants minus dH plus sines upon dt, here for BRO3 minus dBRO3 minus upon dt, here that is 3 is present. So, you can write here minus 1 upon 3 into dBr minus dt. Now, you can put the product concentration of product is increases. So, plus sign is present and number stoichiometric number is present 1 upon 5 into dBr2 upon dt. Now, you can see here dH2 upon dt. Now, my dear students, here you can see the which of the following relations correctly represent the consumption or formation of product. Here these are the formation of product, my dear students. So, you can see the formation of product dBr upon dt. So, dBr minus dt and dBr2. You can see only 2 relation, this only 2 relation is present in all the options. So, you can see here rate of reactions 1 upon 3 dBr minus dt, that equal to 1 upon 5 dBr2 upon dt. My dear students, when you can put that this dBr2, then this 5 is present above upper side 5 by 3, and Br minus you can minus sign is put. So, you can here get the options that equal to dBr2. Here you can see the options dBr2 upon dt. Which option is correct, my dear friends? You can see here correct option is here, that is 5 by 3 dBr2 upon dt. So, when you put the dBr minus, this 3 is gone to away. So, 3 by 5 dBr minus. So, my dear students, here you can see here all the options, in all the options dBr minus, he want the dBr minus upon dt, that equal to 3 is present here, 3 by 5 plus sign is there, dBr2 upon dt. So, you can get two relationship, number 1 of this and number second one is this. Now, check the option. In option you can this type of relationship here, dBr is equal to plus 3 by 5. Here you can see the option B is the correct answer, because in option B you can see that this 3 by 5 Br2 dBr2 upon dt. Now we can go to the question number 10. For the reaction H2I2 to Sturgeon gas, the rate of reaction is expressed. Same concept is there. Rate of reaction is equal to minus dH2 upon dt, my dear students, minus di2 upon dt, that equal to 1 upon 2 plus dhi upon dt. Here, my dear students, you can see the options. dH2 upon dt, yes, but minus sign is not placed, that wrong answer. Here minus is present for the reactant here, you can see here. So, you can go to the option B, my dear students. Question number 10th, option is B. Now, we can go to the question number 11. My dear students, this question is asked in NEET 2017. Here, we can see the question is that overall order of reaction will be, my dear students, we can calculate the order of reaction or rate of reaction for slow reaction. So, my dear students, you can see the only slow reaction x plus y2 to give xy plus y. And here when you can put the order of reaction, rate of reaction is equal to, that equal to concentration of x. Here you can put the power x into k into x and y 2. Here these are the order of reactions. Now we can see here because this in question this is a equilibrium constant. So, my dear students, here for this equilibrium constant you can see the values of k and put the values of k with the help of this option 1. Here you can see here x2. When you can see the x2 divided into two parts, 2x. And when you can put this k, then k is equal to x into x upon x2. Here you can say x square upon x2, that equal to k, my dear students. When you can get the values of x, because here if you can put the values of x also, if values of x, then values of x is equal to, x square value is equal to k into x2. Then you can put the values of x, that equal to root k into x2. Here, my dear students, you can put the values of x, that is k into root k into x2 into, my dear students, y2, because here no number is present. So, if no number, any number is not present here, you can put the number 1. So, you can also, my dears, put the number 1. Now, we can here see that rate of reaction ROR, rate of reaction, when two constants are multiplied with each other, you can get the new constant into x2 ki power 1 by 2. Why? Because root x2 is also say that x2 ki power 1 by 2 and y ki power 1. So, my dear students, here this is the constant, new constant, x and y. Here order of reaction, this is the order of reaction here, these are the order of reaction. So, 1 plus half and this order of reaction you can get the 1.5. So, order of reaction, my dear students, it is a 1.5. So, your answer is C. Question number 11, you can get the answer C. Here in this type of question, my dear students, when equilibrium is present, you can see when equilibrium is present, then first of all you can put the formula, basic formula, rate of reaction is equal to concentration of reactant. After the put the basic formula, my dear students, you can see that one of the reactant is present in another reactions, which is as fast reaction, and by this reaction you can get the values of that reactant and put the values. Here you can see the x and you can get the values of x from this equation and put the values of x and get the order of reaction. This is the concept and this is the trick, and how to can solve the problem, this type of problems. I hope, my dear students, you can solve in this type of all the problems in your book or in your questions paper, old question paper, previous question paper. Now we can go to the question number 12, my dear students. The decomposition of phosphine on tungsten at low pressure is at first order reaction. It's because my dear students, here this is a theoretical question. This is the tungsten metal, okay, and he say that tungsten metal, phosphine, first of all, phosphine is a gas. These phosphine molecules are adsorbed on the surface of this, and when these phosphine molecules are adsorbed on the surface of this, these are the surface molecules, and when these surface molecules, phosphine is adsorbed, these molecules are adsorbed, then at low pressure, my dear student, it's a first order reaction. It means number of molecules of phosphine adsorbed, then number of molecules is dissociated. It means it's a first order reaction. So you can say that, my dear students, a rate is proportional to the surface coverage. Here rate is proportional to the surface coverage, because rate of reaction, here rate of reaction is that when phosphine is decomposed into phosphorus and hydrogen, and number of molecules phosphine is adsorbed, same. So it is a constant concentration in the surface of tungsten, so it is called first order of reaction. So my dear students, you can also say in that way, rate is proportional to the surface coverage. This is the question number 2. Now we can see the question number 13. The rate constant of the reaction A to give B is 0.6 into 10 to the power minus 3 moles per liter. If the concentration of A is 5 molar, then concentration of B after 20 minutes is, my dear students, when you can calculate the concentration of product, here you can use the concept and formulas. Calculate the concentration of product, then my dear students, then you use following formulas. We can see here in these formulas, concentration of B, that equal to K into, K means a constant, K into time T. You can use this type of formula and get the concentration of B. Here this is the time T. Now we can calculate the K constant. Now here it is given as K is given. So K is not calculated by you because K is given in this question, 0.6 into 10 to the power minus 3. And my dear students, time is given, that is 20 minutes, but you can calculate the order of reaction in seconds. Then you can convert it 0.6 into 10 to the power minus 3 multiply by 20 minutes into 60 seconds. So it is, my dear students, convert into seconds. So you can get the 720 into 10 to the power minus 3, or my dear students, you can get the 0.72 molar. When you calculate the 0.6 into 2, 12 and 72, then you can get 720 10 to the minus 3 here, and after this, or 720 divided by 1000, you can get the 0.72 molar. So my dear students, answer is C. Question number 13, you can get the C options. This question is also asked in 2015 year NEET exams, and you can remember this formula, my dear students, concentration of B, that will do K constant into T time, and this is the product, my dear students. Concentration of B means product. Product concentration is always calculated in this way. Now we can see the question number 14. For a reaction between A and B, the order with respect to A is 2 and the order with respect to B is 3. The concentration of both A and B are doubled, the rate will increase by a factor. My dear students, here you can see the concept. My dear students, for first order reaction, rate is equal to K into A concentration. Here power is 1, so it is called first order reaction. When you double the concentration, rate of reaction is also double. When triple the concentration, rate of reaction is also triple. So it is for first order reaction. Now we can see here for second order reaction, rate is equal to Ka ki power 2. My dear students, when you double the concentration, 2 2s are 4. If you double the concentration, then rate is equal to increase by 4 times, means 4 R2 you can get, because it is a second order reaction, A ki power 2. Double the concentration of A, 2 2s are 4, rate is increased by 4 times. Now my dear students, you can see the third order reaction. Rate is equal to K A ki power 3. My dear students, when you increase the rate of reaction, when you can double the concentration of A, then you can see here rate is increases by 2 2s are 4, 4 2s are 8 times. So my dear students, here you can say 8 R2 is equal to 2 A ki power 3. And for zero order reaction, rate is independent. A ki power 0 means rate is not depends on concentration. Double the concentration, 2 R2 is equal to 2 A ki power 0. Any power 0 means that equal to 1. So this R2 is not affected by the doubling the concentration in zero order of reaction. So my dear students, it is a very important concept, and maximum questions are asked in NEET exams or your board exams in this concept. Now we can see here in this question, a reaction between A and B, the order with respect to A, here rate is equal to K A ki power 2, because it gives second order, and B ki power 3, it gives third order. When he say that concentration of A is double, twice A ki power 2 and twice B ki power 3, then my dear students, double the concentration of A and B. What is the rate? 2 2s are 4 here, here 2 into 2 into 2, you get 8 times, here you can get 4 times, and 4 and 8 is multiply, that way you can get this 32 times. So my dear students, question number 14 answer is C. Question number 14 answer is C, and you can get this concept. By this concept you can get the answer. Now we can go to the question number 15. Same concept is applied in this question. Rate is doubled when the concentration of B is double. Rate is equal to K into A and B. When concentration of B is double, then rate is double, means B order of reaction is 1. The rate increases by a factor of 8 when the concentration of both reactants A and B are doubled. It means, my dear students, it is a 1 and it is a 2. When it is a double, rate is double, here double rate, and here rate is increased by 4 times. So then multiply, you can get the 4 2s are 8, means rate of reaction increases by 8 times. In this way you can calculate the rate of reaction A ki power 2 and B ki power 1, and you can get the answer D. Rate is equal to K A ki power 2 and B ki power 1.